Hi everybody. I'm videotaping this on Friday morning, 2-hour delay. We are going to have class today, and I'm going to do this same lesson with you, but I want it videotaped and I want it on the classroom in case you're absent or in case you need to go back and see some things on it. It's newer stuff in some cases, so I want to have it on record so that you can always go back for it. Okay? So a couple of new things now. You are going to get this from me, and I am going to be doing the examples on that. So you need to kind of be following along with that here. So the first one, example 1, it gives you a polynomial that's not in order. And we're trying to determine whether it's a polynomial in one variable. This is kind of the easiest part of what we're doing. You have to rewrite it so that it goes from to the fourth power, to the third, to the second. It has to be in declining order. So you might need to rewrite the polynomial. So I've rewritten it like this, and you have to identify the degree. It's kind of the vocabulary word that we're using now, the degree, which is the exponential term right there. So it's the fourth degree. And the lead coefficient. This is important. The lead coefficient, the coefficient that goes with the highest degree, in this case is -2. Okay, so we're going to be coming back to that a little bit later when we do some things there. Now, here is a polynomial that's not in one variable because it's got the xy here. So that would be a reason why it's not in one variable, so you just kind of leave it like that. Okay? Now, example number 2 and 3. Example number 2 is right here, and we've done this before. It shouldn't be much of a new topic for you. The function for x is here, x to the third plus 2x squared minus 10x plus 20. So what's the value when x is -5? So you substitute -5 in for x. Do all the math. I didn't do it all out. I'm just showing you the substitution that you're putting -5 in for x. Okay? So you do all the math, keep track of all your negatives, you will get -5 as an answer. Example 3. Here is our function g, and when x is here, this is the rule, this is the function. But what if instead of x, we substituted a squared minus 1? Here was just a single number, and we could evaluate. Here, we take a squared minus 1, and we put it in for each of the x's right there. So then we have a squared minus 1 squared plus 3 times a squared minus 1 minus 4. You've got to do all that math out and collect the like terms. This, everybody, is foiling. And I'll give you a little quick foil on it. A squared minus 1 squared. So it becomes that. You then have to do this. A squared times a squared is a to the fourth. A squared minus 1 is minus a squared. Minus 1 a squared. Minus 1 times minus 1 is plus 1. So I'll let you continue to combine like terms, but that's what this is. A squared minus 1 squared, and you have to use your rules of exponents. Okay? So there's another new thing that we have. Giving you a little break here. Now, we have to go to the back. And it should look, I've got my notes on here, but it should be a little grid there. And it says graphs of polynomial functions. So, the end behavior. We're now talking about end behavior of functions. And there's a little chart right there. And the first one says, if the degree is even and the lead coefficient is positive. So here's one that you know, x squared plus, how about 2x squared plus 7 minus 3. The degree is positive, the lead coefficient is an even number. The lead coefficient is 2. That means when the first part says f of x is approaching the positive infinity as x is approaching negative infinity. And what that means is this. The x on this, it's a parabola. X is approaching negative infinity. It's going on forever. But the end behavior is that it's going up. So, and this one is going up here. So when it's even and positive, it's going to be going, the end behavior is up, up. Okay? That's what the first one says. The second one says, if the end degree is even and the lead coefficient is negative, then it's down, down. If it was that, and say I change that to the fourth, what we would have is, if it's even and negative, it's the end behavior is down, down. The end behavior of the polynomials will be going down. This crosses the axis. We're going to have no more than 4 zeros. It might look like this. 1, 2, 3, 4. 1, 2, 3, 4 zeros. It doesn't have to be 4 zeros, but that's the most. The end behavior is down, down when it's even and negative. Okay? Kind of like if this was squared, it would just be a parabola like that. Okay? So there's that one. Now we get to the third one down. If it's odd, the coefficient is odd, and the lead coefficient is positive, then we're going to go down and we're going to go up. Meaning this. If it's 2x to the third, positive and odd. Odd and positive. Something like that. End behavior is down here, but positive here, because we've got 1, 2, 3 zeros crossing through. Okay? So there's when the exponent is odd and it's a positive coefficient. And then if it's odd and a negative coefficient, then we're going to have the opposite the other way, here and here. So, negative coefficient, odd number there, it's going to be something like that. Okay? Going up on the left side and right. It might be somewhat, one thing you should kind of know is if it's odd, you've got to have opposite sides on there. Okay? Because they can't be going the same way. That's certainly one way to think about it. Okay? And, you know, with a negative slope, you kind of think about this second side here. Because this is negative, maybe a negative slope, looking at it that way. So that's going to be the idea of end behaviors. I'll talk about it more in class, but this is your review if you need to have a chart, plus it's on your paper. All right?